In this question, two towers on top of two hills are 40 kilometers apart. The line joining them passes 50 meters above a hill, halfway between the towers. Let's try to understand these two sentences by drawing pictures. There are two towers, and then the distance between them is 40 kilometers. Now there is a hill halfway between the towers, which means nearly at a 20 kilometers there is a hill. Okay. And now the line joining them passes 50 meters above a hill, which means this line is at 50 meters above the tip of the hill. Now, the question is, there's a radio wave sending from going from tower 1 to tower 2 and tower 1 to tower 2, and we have to find out what is the longest wavelength of radio waves that can be sent between these towers without a diffraction effect. Okay, so to answer this question, let us first understand what is Fresnel distance and what is Fresnel diffraction also. So now there is a single slit, and then there's a light source which emits lights, and then the light passes through this slit. Okay, so according to ray optics, if you see this light passes through this slit on the screen, you will have a bright spot. That's all. Okay, but according to the wave optics, light bends this corners. Okay, and then it will have a diffraction effect, and then we will have a spreading of light on the screen like this. So this is a screen. So this is a spreading of the light, and then this is according to wave optics, and this is according to ray optics. Now, there is a specific distance between this slit and the screen, for example, D, um, beyond which you will not have the bending of light. Okay, that is called a Fresnel distance. So, for example, if there is a if you adjust the slit distance from the screen here, and then you will have only bright spot at this bright spot at the center, which means all the light just reaches there without bending. Without bending means without a diffraction effect, and that distance is called ZF. ZF equals a squared divided by lambda, where a is the slit width, okay, and then the lambda is the wavelength of the light used. Okay, with this relation you can find out the lambda. We are going to find out a lambda. Now what is ZF and what is a squared here? So what is the ZF? That is a Fresnel distance between the slit and the screen. Okay, the now screen is actually the another tower, and then the slit is actually the obstacle, that is the hill. Okay, so where is that hill placed? It is at 20 kilometers, so this will be 20 kilometer, and now this is actually the aperture here, this distance. Okay, that is 50 meter. Okay, got it. So with that we can calculate a lambda. Lambda equals a squared, that is a 50 squared, divided by ZF is 20 kilometers, so 20 into 1000 meters. So you can calculate lambda with that, so in terms of meter.